everyone. I'm going to scroll off here. I'm going to do the third and fourth page. Should not be taking too long on our notes, our interactive note system. Sorry that this is taking so long, but I just feel like if I go through it step by step, that you guys will get it. Okay, I'm going to go ahead and switch over. Okay, so it should look like that, and I'm actually going to switch over right here. Okay, so I have this sheet and I have atom A, atom B, atom C. And then actually the next page is atom A, atom B, atom C. Once again, we are, this is the wrap up, but I want to focus on the isotopes. Oh, come on. So it's actually this page when I present, okay? So from before, from the top page, at the very top, or the second one, is that if you notice that the reds were protons, okay? And the pluses, because protons have a positive charge. All right, and this is a copy of the atoms sheet. This is so that I don't have, I do it for you. It's already done, okay? All right, so really quick. There's my son trying to creep by.
I'm giving you the orange slice.
Okay. Alrighty. So, sorry. Okay. So on this one, you'll have to get a periodic table. I'll have it uploaded. But here I have 1, 2, 3 protons. And then I have one, and I'm assuming that these are the neutrons because they live in the nucleus. 1, 2, 3 neutrons. And then 1, 2, 3 electrons, because electrons are negatively charged and they live in the electron cloud. Okay. All right. Protons determine the atom. Okay. So this one we have 3 protons. Okay. This case we have 1, 2, 3 electrons. Now I want to stress once again, I went off for quite a while, that the electrons do change, but for all intents and purposes, we're not really concerned about electrons. But if you see this guy, see that he's all on the outer shell, all alone, and these guys have these 2 shells. Well, it wants to be happy, so it doesn't tend to do that. Okay, so this next one is 3 neutrons. Okay. The atomic number is always the number of protons. So I'm going to say that it's 3. So I think I'm going to go ahead and hide if I can. Nope, it's in the background. I apologize. I can't. So atomic mass. All you do in atomic mass is you add the protons and the neutrons for that element. The only thing you need the periodic table is the atomic number and the symbol or the elemental name. Okay, so we had 3 protons, 3 neutrons. 3 protons, 3 neutrons. And that equals 6. So I don't care on this one if you use the symbol or the element name. I prefer that you, when you do this, it is lithium. How do I know it's lithium? You can put Li. I'm okay with that. Now, how do I know it's lithium? I come to my periodic table. I look for the number 3. Boom. Done. It is lithium. See that number 3 on the top, right above the Li? So you can write the symbol or, and I spelled that wrong. Okay, now let me count the protons. One, two, three. Electrons. One, two, three. Correct. Neutrons. One, two, three, four. The atomic number is the number of protons. So on this, guys, there's going to be three numbers that are the same. Protons, atomic number, and electrons. So if you get, that's what I always say, and usually I have you highlight so that you guys can see that the highlighted ones are going to be the same. So like protons would be yellow, atomic number will be yellow, and then electrons will be like pink. So you know that they're all the same, but electrons do change eventually. Okay, I'm sorry. Come on. Okay, so our atomic number is 3. Now, our mass number is what you calculate in the nucleus. So it's just the black and the gray guys. Okay, 1, 2, 3, 4, 5, 6, 7. Or 3 plus 4 equals 7. Either way is to do it. And the element again, so I need to look at the number of protons. I'm going to go back to my handy dandy periodic table if my computer cooperates. Oh, come on. And I need to find 3 protons. Oh, it's lithium. It is not nitrogen because of the 7. No, 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 no. No. Okay. It is not. Yeah, it is not. So again, since it's 3 protons, it is lithium or Li. But Ms. Kaufman, we already had lithium. Lithium, it doesn't matter. This is like your siblings. This is kind of your last name. This is who identifies you. It's actually not your last name. It is your genetic makeup. No matter what, you're going to have the genes handed down to you. And that's the same thing with the protons. They identify the element. So let's go to the next one. But I have 2 lithiums. It doesn't matter. That's what makes an isotope, is that you have the same amount of protons, but you can have a varying amount of neutrons. An ion, I-O-N, is a varying amount of protons and electrons. Okay, so the proton here, let's count. Oh no, we can be the count. 1, 2, 3. The count on Sesame stops. So we found 3 protons. Once again, we found 3 electrons. And let's count the number of neutrons. 1, 2, 3, 4, 5. There are 5 neutrons. The atomic number is, the amount of protons is 3. The atomic mass is, we count these guys in the middle, the nucleus. 1, 2, 3, 4, 5, 6, 7, 8. Or 5 plus 3 equals 5 plus 3 equals 8. What element is it again? It is, let's go one more time. It is what element? 3 protons. Up! It's lithium again? Yes, it's lithium again. Because it's an isotope. It's just a different type of lithium. Okay. One of the key things on this, isotopes are awesome. I just saw them on another thing about murder mysteries. But if you've ever watched, it was, you're gonna kill me all. But if you've ever watched the first Captain America movie and it's Red Skull, sorry, he was famous for making heavy water, and that's when he used hydrogen in H2O that was heavy, meaning it had a different amount of neutrons. And it does create some different properties of water if you use a heavy, it's called heavy water. And it makes different properties of water, and we don't want to drink a lot of that. And we do by natural means, but very, 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 very rarely. Okay. All right. So I'm going to stop here. Oh, I'm going to write this at the bottom. Sorry. Atoms are, excuse me, iso means different, tope means type. Now, why we don't call it different type, I don't know. But iso means different, tope means type. So it's a different type of atom. Isotope atoms are the same number of, if I could get it going here, protons, but different amount of neutrons. For example, we have three types of lithiums up here. We have lithium, and when we start up next semester, I'll teach you guys that it's actually lithium 6, lithium 7, and lithium 8. And how they're that way is because we definitely know that lithium has 3 protons because it wouldn't be lithium if it wasn't that way. But this just shows the mass of different neutrons. So we don't have to write a ton of stuff down. And there's some easy ways to do this. Why are isotopes important? Well, they're very important in the sense with nuclear energy. Nuclear energy is basically what gives us 20 to 30% of energy at all time here in the state of Kansas. I find it very important, no greenhouse effects, so you don't get CO2 or sulfur dioxide up in the clouds. No cause of acid rain. But if you go research Chernobyl and Fukushima, and a really crazy thing that happened on right before V-Day in 1945 in Japan. Think about it. So, alrighty. Okay, I will see you all. Have a good one. And really, really, really quick, that you guys need to do the next page. And if you have any questions, holler at me. Just a trick. Look how many positives there are. Might be helping you out a little too much. All right. Bye, guys.